When you go to the theater, you watch the actors,
I do confess that I love nothing in the world so well as thee.
the scenery, the story.
But I protest, I love thee.
Well, then, God forgive me.
What offense, sweet Beatrice?
But there's something important here that you won't find mentioned in the playbill.
Something we hardly ever notice. The stage. It's an absolutely vital part of the show, and yet most of us, we don't even give it a second thought. But Isaac Newton, he did. This is how the father of modern science pictured space, as an empty stage. To Newton, space was the framework for everything that happens in the cosmos, the arena within which the drama of the universe plays out. And Newton's stage was passive, absolute, eternal, and unchanging. The action couldn't affect the stage, and the stage couldn't affect the action. By picturing space in this way, Newton was able to describe the world as no one had ever done before. His unchanging stage allowed him to understand almost all motion we can see around us, yielding laws that can predict everything from the way apples fall from trees to the path the Earth takes around the sun. These laws worked so well that we still use them for the things we do today, from launching satellites to landing airplanes. And the laws all hinge on one radical idea: space is real. Even though you can't see it or smell it or touch it, space is enough of a real physical thing to provide a benchmark for certain kinds of motion, like that skater. Newton would say that when she spins, her arms splay out because she is spinning with respect to something, and that something is space itself.
Philosophers have been debating the nature of space for a very long time. What Newton does is change the terms of the debate. And with that, essentially modern science gets born.
Newton's stage was a huge hit. It enjoyed the limelight for over 200 years. But in the early decades of the 20th century, a new set of ideas emerged that shook Newton's stage to its very foundation. Ideas put forward by a young clerk working in a Swiss patent office. His name? Albert Einstein. Einstein grew up in the late 1800s, at the dawn of the age of electricity. Electric power was lighting up cities, giving rise to all kinds of technologies Newton could never have imagined. All of these developments tapped into something that had captivated Einstein since he was a child: light. Not light bulbs and street lamps, but the very nature of light itself. And it was his fascination with one particularly weird feature of light, its speed, that would lead Einstein to overturn Newton's picture of space. To see how, let's take a ride. Right now, we're traveling at about 20 miles per hour. And to go faster, all the driver needs to do is step on the gas, and the cab speed changes. Now, you can feel that change, but you can also see it on the cab speedometer or on one of those radar speed signs. Okay, you can slow it down now. But now imagine that instead of measuring the speed of the cab, you have a radar sign that measures the speed of the light coming off its headlights. That sign would measure the light traveling at an astounding 671 million miles an hour. Now, when the cab starts moving, you'd think that the speed of the light would increase by the same amount as the car. After all, you'd think that the moving cab would give the light an extra push. But surprisingly, that's not what happens. Our radar sign or any measurement of light speed will always detect light traveling at 671 million miles per hour, whether the cab is moving or not. But how could this be? How could all measurements of light speed always come out the same?
If you're running at a wall, it's coming at you faster than if you're standing still with respect to that wall. But that's not true with light. The speed of light is the same for everybody. That's really extraordinary.
So here's how Einstein made sense of this extraordinary puzzle. Knowing that speed is just a measure of the space that something travels over time, Einstein proposed a truly stunning idea: that space and time could work together, constantly adjusting by exactly the right amount, so that no matter how fast you might be moving when you measure the speed of light, it always comes out to be 671 million miles per hour.
To respect that absolute quality about light, time had to cease to be absolute, space had to cease to be absolute, and those two had to become relative in such a way that they slosh between each other.
If space and time being flexible sounds unfamiliar, it's only because we don't move fast enough in everyday life to see it in action. But if this cab could move near the speed of light, the effects would no longer be hidden. For example, if you were on a street corner as I went by close to the speed of light, you'd see space adjusting so that my cab, it would appear just inches long. And you'd also hear my watch ticking off time very slowly. But from my perspective, inside the cab, my watch would be ticking normally, and space in here would appear as it always does. But when I look outside the cab, I'd see space wildly adjusting, all to keep the speed of light constant. So with Einstein, time and space are no longer rigid and absolute. Instead, they meld together with motion, forming a single entity that came to be called space-time.
I think as we live our life every day, we live with a Newtonian picture of space and time. It's something that we're comfortable with. But Einstein was able to make reason conquer sense. And that really was the genius of Einstein.
This notion that space and time are unity, to me, is one of the greatest insights that has ever occurred in science. It's so counterintuitive to everything we've ever experienced as human beings.
And in the hands of Albert Einstein, this new picture of space would solve a deep mystery having to do with the most familiar force in the cosmos: gravity. Newton knew that gravity is a force that attracts objects to each other, and his laws predicted the strength of this force with fantastic precision. But how does gravity actually work? How does the Earth pull on the moon across hundreds of thousands of miles of empty space? They behave as if they're connected by some kind of invisible rope. But everyone knew that wasn't true. And Newton's laws provided no explanation.
Einstein found that no Band-Aid patches would fix Newtonian gravity. He had to invent a mechanism for it. He had to understand it.
After puzzling over this problem for more than 10 years, Einstein reached a startling conclusion. The secret to gravity lay in the nature of space-time. It was even more flexible than he had previously realized. It could stretch like an actual fabric. This was a truly radical break from Newton. Think of this table as space-time, and think of these balls as objects in space. Now, if space-time were nice and flat, like the surface of this table, objects would travel in straight lines. But if space is like a fabric that can stretch and bend, well, this may seem a little strange. But watch what happens if I put something heavy on the stretchy space-time fabric. Now if I take my shot again, the ball travels along an indentation in the fabric that the heavier object creates. And this, Einstein realized, is how gravity actually works. It's the warping of space-time caused by the objects within it. In other words, gravity is the shape of space-time itself. The moon is kept in orbit not because it's pulled to the Earth by some mysterious force, but rather because it rolls along a curve in the space-time fabric that the Earth creates.
With Einstein, space became not only real, but flexible. So suddenly space had properties, suddenly space had curvature, suddenly space had a flexible kind of geometry, almost like a rubber sheet.
It opens up a whole new way of thinking about reality that describes the entire universe. Einstein becomes Einstein because of that observation.
Where Newton saw space as passive, Einstein saw it as dynamic. It's interwoven with time and it dictates how things move. So, after Einstein, space can no longer be thought of as a static stage. It's an actor, and it plays a leading role in the cosmic drama.